So, welcome everyone for coming today. For those of you returning, this is an IC Impacts and UBC Future Waters collaboration. And if it's your first West student talk, then welcome. So WESTalks, we aim to bring together leaders on sustainable water and environmental research from around the globe, as well as students who are interested in this space as well. And so it's hosted by UBC with collaboration with the University of Guelph, and then I myself am at the University of Victoria. So it's a big collaborative situation. Slide goes forward. Here we go. So IC Impacts is a Canada-India Research Center, and UBC Future Waters is a UBC Research Excellent Cluster. And so both of these organizations, committees work together to put on this seminar series. And this is our last one of 2021. And we already have a full lineup planned for next year, which is very exciting. So our organizing committee consists of all of these wonderful people, and some of which are here today as participants, and some aren't just due to traveling and whatnot. So like I said, most of us are at the University of British Columbia. I myself am at the University of Victoria, and then we do have another member at the University of Guelph as well. So if you haven't done so already, if this is maybe your first time attending this talk, we do like to sort of map out where everyone is attending from, where they're doing their research. And so we have a link in the chat for you to put your location on our map, and then we always keep it updated as we go along. It's fun to see where everyone is coming from. So today we have Alexandra giving our talk. So today is the 16th. As you can see, we've had speakers throughout the fall term. Those videos are online on the IC Impacts YouTube channel. And looking forward into next year, we do have a full lineup of speakers already booked, as you can see here. So you can start penciling those in into your schedule for the new year. Like I said, previous WESTalks are available on the IC Impacts YouTube channel. And without further ado, I will introduce today's speaker. So we have Dr. Alexandra here with us today. She's a postdoctoral fellow at the University of Laval and a visiting researcher at the University of Ottawa, working on drinking water supply and domestic hygiene in low resource settings, low and middle income countries, and remote northern communities. She holds a PhD in civil engineering from the University of Victoria. Her research expertise lies at the crossroad of environmental engineering, public health, and geography. She worked as a consultant with the World Bank's Water Supply and Sanitation Global Solution Group as an intern with the Water Sanitation Hygiene Unit at the World Health Organization. She's involved through research and teaching, as well as currently engaged as a member of CIE. I'm not going to try and pronounce that in French because it'll be terrible. I apologize. In 2020, she received the prestigious Green Talents Award as one of 25 young scientists with high potential and sustainable development by the German Federal Ministry of Education and Research. And today she's going to be talking about a part of her postdoctoral research, which is quite exciting, and we're very lucky to have her here today. So she'll be giving her presentation, and if you have any questions that pop up during this time, please feel free to put them in the chat box, or you can raise your hand at the end of the presentation and we will have time to go through those. So I will stop sharing my screen and let you take over.
All good? Can you see? Okay, sounds good. Thank you, Kelsey, for the nice introduction. Thank you. And thank you for being here today. Thank you for this invitation to present at WESTalk. So yeah, my name is Alexandra Cassivi and I'm a postdoctoral fellow at the Université Laval. I'm working with Manuel Rodriguez at the Université Laval and Stéphanie Guilherme at the University of Ottawa. And as Kelsey said earlier, my research focused on drinking water supply, domestic hygiene, and health in limited resource settings. And yes, I recently graduated from the University of Victoria, where I conducted my research activities in Malawi. And as part of my doctoral research, I'm working in a very different environment, which is more northern. And so I'm doing my research in remote Arctic communities. So again, I'm very happy to be here this morning to talk about drinking water challenges in remote Arctic communities. And so the Arctic, located north of the 66th parallel, accounts for 30% of the Canadian territories. There are over 20,000 people living there, more than half of whom come from Indigenous communities. Our research is currently focused on Inuit Nunangat, that is Nunavut, as well as the northern portion of Quebec and Labrador, which includes 51 Inuit communities. Generally unable to provide an underground distribution network due to the presence of permafrost, the supply of drinking water remains an important issue in the communities. In Inuit Nunangat, only a few communities are served by a running water supply network, meaning a pipeline distribution system that goes directly to home, similar to those we find here in the south. In Labrador, a pipe water supply system is available, but considered unsafe for consumption. As a result, in 3 communities, households must collect water directly from a collective distribution unit located in the village in order to obtain safe drinking water. Finally, the majority of communities, more than 80%, are served by a tank truck supply system. So as you can see here on the graph to your right, most of the communities are served by truck to cistern. So as of now, we focus our research activities on truck to cistern water supply in Nunavik. So Nunavik is the northern part of the province of Quebec. There are 14 northern villages in Nunavik and approximately 13,000 inhabitants. So more specifically, we have recently conducted fieldwork activities in Kanjik-Sulujuak, which is one of the northern communities in Nunavik, located at the mouth of the George River on the east coast of the Ungava Bay in Nunavik. So in Kanjik-Sulujuak, there is approximately 275 households and more or less 1,000 inhabitants. And so in Kanjik-Sulujuak, like in all except 1 communities in Nunavik, drinking water supply and wastewater collection is provided with a truck to cistern system. So I will go further into what this means. So what does it mean? More specifically, for drinking water, we start with the water source. So we have the water source. And so water goes to the water treatment plant. So this is for Kanjik-Sulujuak. So the system may vary a little bit in the different communities, but this one is really for Kanjik-Sulujuak. And so after the water treatment plants, then the cistern trucks takes over to make sure that the water is delivered to the different building units in the communities. And so we have residential units and also public buildings. And so water is stored in a water tank. But we also have a public tap that is available for people to collect water directly at the water treatment plant. So I was saying earlier that in some communities, we have only distribution unit, but in this community, we have both. So we have a truck to cistern. And so we also have public tap. So people also do collect water from the public tap. And so when they collect water, they use containers that they bring back home in their home. But also we have alternative sources that are used by the communities, by the people especially for drinking water. So people don't necessarily use water for hygiene, but for drinking purposes, then people do collect water at other places than using the water from their tap, because they do have tap. It's just that the water is really stored into water tanks. And so we have different challenges associated to production, distribution, storage, but also practice and preference for drinking water. And so I will discuss all of these a little bit further so we can have a better idea of actually what are the different challenges. So the main, so now how do we ensure safe, affordable, and sufficient access to drinking water from the water source to the point of use? And so there are multiple challenges that relates to the supply system. So first, in terms of drinking water production, then we have to find a reliable water source. And so in general, in Nunavik, the sources are quite good. The water is already clean because there's very few sources of contamination. But some people do also work on this to make sure that those sources are acceptable. And so water goes to the water treatment plant. And so we want to make sure that the treatment is adequate for the population, that the water quality is good enough for consumption, but also that the water that is actually produced is acceptable for the communities. And so in the case of this community, what we see is that people don't necessarily like the taste of the water. So there is a very, very low level of chlorine that is actually introduced in the water treatment plant. And so this can lead to different problems just because we have, for example, a very low level of chlorine at the water treatment plant, but then the water can stay in the truck for a few hours, for example, before being delivered into the households. And then it may take a few hours, few days sometimes before the water is actually used. So once we have actually potable water, then we want to make sure that there's safe water quality from the water treatment plant to the point of use, that the trucks and actually the road that are used to deliver the water are actually in good operation. But we find sometimes some problems because trucks are broken, because some of these trucks that are used, as you can see on the picture, are quite old. And so they require good maintenance around the year. And also it's also really cold in the winter. So you can imagine the different problem that we can find. And if something is actually broken, then the piece to repair need usually to be sent from here, from the south. So it may take a few days, few weeks. And so what we saw in August is that the community was actually left for 2 weeks without any delivery because the 2 trucks were broken. And so people had to rely on different other sources to meet their need in water for consumption, but also for hygiene. And so when the system is actually working, we want to make sure that the distribution frequency is sufficient to ensure water availability for a few days. Especially because if the truck stops the next day, then we need to make sure that people do have enough water, enough quantity to meet their needs. And so in these storage and water tanks, what we find is that some house, so we have also single unit housing, but we also find that some house do have multiple units. And so the water tanks are actually shared between the different households. The mechanical room where we find the water tanks is not accessible by the population. It's really the housing office that take care of these water tanks. Also for cleaning, which is usually being done once per year, but sometimes it may take more than a year. Also we need to make sure that the quantity is sufficient for the multiple units to make sure that everyone gets enough water. groups. And so all of these challenges that are associated to the distribution system, and also the fact that people don't necessarily accept the taste of chlorine, and so they don't want to drink the water that comes from the tap, means that people actually have other practice or preference for their to meet their needs. And so they use alternative water source. So as I was saying, some surface water, bottle of water as well, but mostly surface water. So as you can see on the pictures here, there is a source that is located near, actually near the airport, so near the road, which is a natural source. So it's half groundwater, half surface water. We're still unsure where the water actually comes from. And so, as you can see, there is some installation that has been made to make sure that people can access safely to the water, because many people use this source, which they call fresh water, and so it's really the source that usually people prefer to use. And so we need to make sure that even if people use this water source, then there is no post-collection contamination that can occur because they use different containers. So the container needs to be clean as well. And so because of the reluctance and confidence in the distribution system, people mostly rely on this source, but it's also a cultural aspect because they've been using, for example, this source since many years. And so it's not necessarily something that is going to change. And the idea is not to change those practices, because this is the practice that they do since many years, as I was saying. So we just need to make sure that this is safe and that they actually get enough water for other needs, because the one that they collect at this water source is only for drinking purposes. And so the objective of our project, after all of these different challenges, is to optimize management of drinking water supply services in northern communities. And so we want to document drinking water supply challenges in the Arctic, establish a portrait, sorry, there's a mistake here, of water quality and availability from the source to the tap, to identify source of contamination and assess risk to human health, and to develop a water safety plan for isolated northern communities. So we've been to Kanjik-Sulujuaq in August and September. So we just came back a few months ago. So I will present with actually what we did, but unfortunately we're still at the step of actually analyzing the data, but yeah. So I don't have any result to present yet, but I'll be happy to come back maybe in a few months and to just present results. But it gives a good idea of actually what we did and what is going to come next. So we've been there with my colleague Anne and Christian as well. And we did a lot of data collection, lots of data on different aspects of water supply. So first, water quality testing, so physical-chemical parameters, bacteria, disinfection by product. And we did the water quality testing really from the water source and different lakes that are around the communities until the point of consumption, so really the household step. So this is the same graph as I showed earlier. It's just to show where we actually did those analyses. And also at the water treatment plant, we did different analysis because we wanted to see what was the impact of the different treatment that are being made at the water treatment plant. So we sampled water after UV treatment, after chlorination, and also at the loading harm to the truck. We also took some samples in the cistern trucks, also in public buildings, at the research center as well, at the public tap, and also from the alternative sources that are used by the population. And so just a little hint here, we have the public tap that is actually not chlorinated. So people do use this one because it's only after the UV treatment. It's what we actually found out. So we thought that the public tap was also chlorinated, but since people use it because they prefer that the water is not chlorinated, they just keep going with this UV treatment. And so after water quality testing, we also did a household survey, which is a big part of this research. So the household survey was distributed in a few households. So as of now, we have 68 households in the same community. So it's quite good because it's very small. So we have a little bit more than 250 households in the community. In the household survey, we wanted to see what people were thinking about the water supply, how we could improve the water supply, if they were using any source of water, and if the water use and quantities are enough to meet their needs. And so, yeah, we have a lot of data, and we're really looking forward to actually analyze this and see if we can find some similarity between some households and between different practices that are being made by the population. We also did some observation, so the cistern truck distribution routes, because we find out that people that are in some areas in the communities are sometimes left without water because it's the end of the day, and so the truck driver just wait until the next day to deliver water in those households. But generally, water is supposed to be delivered each and every day. Also, we have the different type of house and the different type of reservoir. So in the single unit housing, compared to the, for example, where four households live, then we find some differences in the quantity of water that is actually stored. And also if there are any differences in the different localization around the communities. And so the next steps are to analyze data and to make the portrait of water supply in this community, especially, and to prepare a second phase for this community, which would which would include actually water collection and post-collection contamination. So we are looking forward to actually see how people use their container and if they clean the container, and to see if there is a relationship between the water that they collect and the quality of the water. So we want to make sure that there are no health risks associated to those practices. Also midterm, we wish to replicate in other communities in Inuit and Nangat. So we have some discussion to follow up this work in Nunavut as well, and to elaborate a water safety plan for this community especially, and mostly to make a template for other communities as well. And so, yeah, that was a little bit about it. Thank you for listening, and I'd be glad to answer any question. Also, if you have any further question, I also welcome any thoughts. You can email me or contact me via LinkedIn. Yeah, thank you.